You're standing in the middle of an Amish farmhouse kitchen in the middle of summer. Outside, the fields shimmer under 90-degree heat. The air is thick, heavy, the kind of heat that makes modern air conditioners groan for mercy. But inside this kitchen, it's quiet. No humming compressor, no electric fan, no buzzing motor hidden behind a stainless steel wall, and yet somehow, the butter is cold. The milk is fresh. The vegetables are crisp. Even the meat stays preserved for days. All inside a refrigerator that uses absolutely zero electricity. No outlet, no batteries, no solar panels. Nothing. At first glance, it feels impossible. Modern society teaches us that refrigeration is complicated, expensive, energy hungry. We're told cold air requires chemicals, compressors, refrigerants, smart sensors, sealed systems, and constant power flowing through miles of wire. But the Amish found another way, or more accurately, they never stopped using the old way. And once you understand how it works, you begin to realize something unsettling, because this refrigerator doesn't just cool food. It quietly exposes how dependent modern life has become. The story begins underground. Long before electric refrigerators existed, people still had to preserve food through brutal summers. Milk spoiled quickly, meat turned dangerous, vegetables wilted within hours. And for thousands of years, survival depended on solving one problem. How do you keep things cold? Without power, most civilizations failed to solve it efficiently. But scattered across Europe and later rural America, certain farming communities discovered something strange beneath their feet. The deeper you go underground, the colder the earth becomes. Not freezing, not icy, but stable. Even during the hottest summer days, temperatures several feet underground often remain around 50 to 55 degrees year-round. The Amish understood this better than most, because unlike modern homeowners, they still lived close to the land. They noticed airflow, moisture, stone temperature, wind direction, soil cooling, tiny environmental details most people stopped paying attention to generations ago. And over time, they developed refrigeration systems that worked almost entirely through natural physics. No electronics, just earth, airflow, insulation, and patience. One version looked deceptively simple. A wooden cabinet built into the north side of the home. Inside the cabinet sat shelves lined with metal containers and stone slabs. But hidden behind the cabinet, a narrow ventilation shaft traveled downward into the ground beneath the house. Cool underground air naturally moved upward through the shaft. Warm kitchen air rose. Cold earth air replaced it. Slowly, silently, continuously. The result was a primitive cooling chamber capable of preserving food far longer than open air storage ever could. And the truly remarkable part, it never stopped running. 24 hours a day, 7 days a week. No fuel delivery. No maintenance technician. No monthly bill. Just temperature differences and gravity doing all the work. To modern engineers, this sounds almost too simple. Because modern systems are built around force. Force the compressor to run. Force refrigerant through coils. Force cold air circulation. But Amish cooling systems relied on something modern industry often ignores. Passive movement. Instead of overpowering nature, they redirected it. And once you understand passive cooling, you start seeing traces of it everywhere. Ancient Persian wind towers, Roman underground storage chambers, root cellars carved beneath farms, even old churches designed to stay cool without electricity. Human beings once built entire civilizations around airflow and thermal mass. Then electricity arrived, and most of that knowledge disappeared almost overnight, because powered systems were faster, more profitable, more scalable, and eventually more addictive. Modern refrigeration changed civilization forever. Suddenly, every home needed constant electricity. Every grocery store depended on massive cooling chains. Entire cities became locked into uninterrupted power consumption. And people forgot there was ever another option. Except the Amish didn't. In many Amish communities, dependence itself became the danger. Not technology necessarily, dependence. If a machine breaks and nobody nearby can repair it, you lose control. If your food survives only as long as the power grid stays alive, you become fragile. So Amish engineering evolved differently. Reliability mattered more than convenience. Longevity mattered more than speed. Simplicity mattered more than efficiency on paper. That philosophy shaped everything, especially refrigeration. Some Amish homes expanded the underground cooling idea even further. Instead of a simple cabinet, they built full spring houses. Small stone structures positioned beside naturally cold underground springs. The spring water constantly flowed through channels beneath shelves holding milk, cheese, butter, and meat. The moving water carried heat away naturally. Even during summer, the temperature stayed shockingly low. In some systems, metal containers sat partially submerged in spring-fed troughs. In others, air cooled by flowing water circulated upward into food chambers above. Again, no electricity, just water, stone, shade, and careful design. What's fascinating is that none of this relied on secret inventions. The physics are straightforward. Cold air sinks. Moving water absorbs heat. Underground temperatures remain stable. Thick stone changes temperature slowly. Ventilation creates circulation. That's it. No miracle machine. No hidden fuel source. Just forgotten environmental engineering. But modern people often struggle to believe simple systems can outperform complex ones because complexity feels advanced. Even when it's fragile, a modern refrigerator might fail because of a damaged circuit board smaller than a postage stamp. An Amish cooling room built from stone and airflow can operate for decades with almost nothing to break. And that difference matters more than most people realize, especially during emergencies. When hurricanes destroy power lines, modern refrigerators become useless boxes within hours. Food spoils rapidly. Entire grocery stores lose inventory. People panic buy ice. Generators roar through neighborhoods, but underground cooling systems continue functioning quietly beneath the chaos because they were never connected to the grid in the first place. That resilience is part of why off-grid communities still study Amish designs today, not because they reject modern technology completely, but because they understand a dangerous truth. Systems that require constant energy are vulnerable systems, and vulnerability has a price. There's another detail about Amish refrigeration most people never hear about: humidity. Modern refrigerators dry the air aggressively. That's why vegetables become rubbery, cheese hardens, bread goes stale faster. But underground cooling chambers often maintain higher natural humidity levels, which changes food preservation dramatically. Root vegetables last longer. Cheese retains texture. Leafy greens stay fresher. Certain foods actually perform better in cool, humid environments than in ultra-dry electric refrigeration. That's why root cellars once stored potatoes, carrots, apples, onions, and cabbage for entire winters. Not through freezing, through balance. Modern refrigeration optimized for speed and standardization. Traditional cooling optimized for stability. Those are very different goals. And you can still see the difference inside Amish homes today. The kitchens feel slower, calmer, less mechanical. Nothing flashes, nothing beeps, nothing demands attention every few seconds. Even the cooling systems operate invisibly in the background, almost like part of the house itself. And maybe that's the strangest part of all. Modern technology often dominates the environment around it. It announces itself constantly, buzzing, humming, glowing, demanding updates, maintenance, subscriptions, electricity, but Amish systems tend to disappear into daily life. Quiet function instead of constant stimulation. That philosophy extends far beyond refrigeration. It shapes lighting, transportation, food storage, heating, even communication. The question was never, can this be more advanced? The question was, can this remain useful for generations? And those are not the same thing. There's an old saying among some off-grid builders: a complicated system fails complicatedly. A simple system fails simply. That idea sounds almost obvious until modern infrastructure collapses. Then suddenly simplicity becomes incredibly valuable. After major blackouts, survival forums explode with discussions about passive cooling, root cellars, ice houses, underground ventilation, solar chimneys. People rediscover techniques their great-grandparents considered normal. Not because society moved backward, because fragile systems reveal their weakness under stress. And refrigeration may be one of the clearest examples. Think about how dependent modern food systems really are. A grocery store loses power for a few hours and entire aisles become dangerous. Trucks carrying refrigerated food burn massive amounts of fuel every day. Warehouses consume staggering electricity around the clock. Modern civilization eats cold food constantly, but only through uninterrupted industrial energy. The Amish approached the same problem differently. Instead of forcing the environment to obey them, they adapted themselves to the environment. And adaptation often consumes far less energy than domination. That principle appears again and again in traditional architecture. Homes positioned for seasonal sunlight, windows designed for cross-ventilation, deep porches creating shade, underground storage stabilizing temperature, none of it flashy, all of it effective. In fact, some architects now quietly study old Amish and pre-industrial cooling methods as climate concerns grow worldwide. Not because they want society to abandon electricity entirely, but because passive systems reduce energy demand dramatically. A modern building that needs less cooling is cheaper to operate, more resilient during outages, and often more comfortable naturally. Ironically, the future may end up rediscovering ideas the past already understood. But perhaps the most powerful part of Amish refrigeration isn't technical at all. It's psychological. Because opening a refrigerator powered by nothing changes how you think about comfort. Modern life trains people to assume convenience always requires massive infrastructure, huge factories, rare earth metals, endless electricity, global supply chains. But then you see cold milk sitting inside a wooden cabinet, cooled by the earth itself, and something shifts. You realize nature was already doing much of the work long before machines arrived. Humans simply stopped paying attention. The Amish never completely stopped. That doesn't mean Amish life is easy. Far from it. These systems require planning, maintenance, patience, physical labor, seasonal awareness. Passive refrigeration cannot always match the precision of industrial cooling. There are limits, but that's part of the philosophy too. Modern systems often prioritize maximum convenience regardless of cost. Traditional systems prioritize sustainability and resilience even if convenience decreases slightly. Different values create different technologies, and every society eventually reflects the tools it depends on. There's another reason these refrigerators fascinate people online today. They represent escape, not necessarily from electricity itself, but from dependence, from monthly bills, from fragile supply chains, from feeling trapped inside systems nobody fully controls anymore. That's why videos about Amish engineering spread so quickly across the internet. People sense something deeper underneath the wooden cabinets and stone walls. A question modern society rarely asks: how much technology do we actually need? Not want, need. Because sometimes complexity solves ambiguity, but sometimes complexity creates ruins. Modern refrigeration certainly did both. It preserved food at unprecedented scale, reduced disease, expanded cities, enabled global trade, but it also tied survival to massive infrastructure networks vulnerable to disruption. The Amish simply chose a different balance point: less convenience, more independence, less speed, more resilience. And whether people agree with that lifestyle or not, the engineering behind it deserves respect, especially because it works. Not theoretically, not experimentally, daily, quietly, for generations. In some Amish communities, children grow up watching parents manage temperature through airflow, shading, underground cooling, and seasonal food rotation. That knowledge becomes instinctive, almost architectural intuition. Meanwhile, most modern people couldn't explain how their refrigerator works beyond it plugs into the wall. That gap matters, because knowledge shapes independence. The less people understand the systems keeping them alive, the more vulnerable they become when those systems fail. And perhaps that's the hidden lesson inside the Amish refrigerator. It isn't really about refrigeration. It's about remembering that human beings once understood how to cooperate with the environment instead of constantly overpowering it. The earth below your feet already contains stable temperatures. Air already wants to circulate. Water already carries heat away naturally. Stone already stores thermal energy. Nature has always been performing complex engineering. Traditional societies simply learned how to guide it. Modern civilization often replaces guidance with consumption, and consumption requires endless input: electricity, fuel, replacement parts, upgrades, subscriptions, constant dependence. The Amish refrigerator quietly steps outside that cycle. No notifications, no smart screen, no app connection, no software update, just cold food created through physics older than civilization itself. And maybe that's why these systems feel so haunting to modern viewers. Not because they're magical, because they're understandable. Deep down, people crave systems they can mentally grasp. Systems
As
that feel
warm ambient
human-sized,
air is drawn
repairable,
underground,
visible,
it is naturally
real.
cooled by the
An
constant
underground
55-degree
cooling chamber
earth
built
temperature.
from stone and airflow feels comprehensible in a way modern industrial systems often do not. And comprehension creates trust. Perhaps that's the real divide between traditional technology and modern technology. Not old versus new, but transparent versus visible. The Amish refrigerator reveals exactly how it works if you pay attention. Modern systems often hide their complexity behind sealed panels and digital interfaces few people truly understand. One system invites participation, the other demands dependence. And in an age where almost everything feels increasingly automated, outsourced, and abstract, that difference carries emotional weight, especially when the lights go out. Because somewhere tonight, while cities glow with electric refrigeration, an Amish farmhouse may still sit quietly beneath the summer heat. No humming motors, no flashing displays, just cool earth beneath the floorboards, silently preserving tomorrow's food the same way it did 100 years ago.